Okay, so this lesson we're going to look at what is acceleration, and just briefly looking at our agenda, we're going to be doing just our warm-up question here. We're going to look at just some acceleration notes with looking at the equation of acceleration, how to get acceleration, the variable acceleration within mathematically, and then we're going to be looking at some practice acceleration graphs and just some final thoughts on acceleration. So our warm-up question here is, what is the equation that shows velocity? If we are looking at velocity, velocity is direction over time. So we have, and velocity also, based on the last few lessons, is that it shows magnitude and direction. So we have, our first is A, our first choice is A. V is equal to D over time. That seems correct. V is equal to D2 minus D1. That would show the displacement between distance. So that seems right on the top, and D2 minus D1, that seems right on the bottom. So our answer would be C. So that's our warm-up. At the end of taking notes for this lesson, we just wanted to find acceleration, and we wanted to find the relationship between acceleration graphically. So first, let's just talk about briefly around acceleration and just how we end up finding it. Now, the first thing I want to do, or first equation, v is equal to a times t. Now, acceleration here is the middle variable, and if we wanted to isolate this one, we're going to be looking at making this v over t is equal to a. We can also end up finding v final minus v initial divided by t final minus t initial is equal to a as well. We can end up finding using any of these equations to find acceleration. Now also within that though too, we could see that because velocity is distance over time, so we can end up using meters per second. Now the unit, I bring this up because the unit too for acceleration is equal to meters per second squared. Now that is huge. That's the squared here. The squared here comes from, if I go back to this equation over here, m over s divided by s. So these two, s1 and s1, that ends up becoming m over s squared mathematically. So you know it's acceleration if you end up having this squared here, which is important. Okay, so going on here, looking at our graphs. Now I want you to keep in mind that meters per second squared, and the acceleration is equal to v divided by t. So because what we have is the first one we have is this is distance. X is just distance over time. These are all the bottoms are time here. Okay, so it's like t over time here, t and t. It just didn't come out very correct there. So so if we have where the distance is increasing and the time is increasing, is our velocity going to be increasing or is it going to be decreasing? Is it going to be negative? Is it going to be positive? So, well, this here, I'm going to just go through 2, and then I want you to do 3, 4, and 5. I'm going to do 1 and 2. I'll do 1 and 2 here, and you do 3 and 4 and 5. So the first one, we're going to see that it is going to be, it's going to be increasing here. Velocity, if you increase in distance and time, velocity is going to increase as well. Now, if velocity is increasing, and the time is increasing, our acceleration is also going to be increasing as well. Oop, let me use a different color here. Our velocity is also going to be increasing as well. Now, going to number 2, if our distance, I'm looking at this here, if our distance is decreasing and our time is increasing, our velocity is going to be going negative. Negative divided by positive is going to be a negative. We're going to end up having where it's going to be downwards. Now, you got to make them arrows as well because they're vectors. So it's going to be decreasing. Now, if our velocity is in the negative and our time is in the positive, we're going to also end up seeing, we're going to also see that it's going to be in the negative. Okay, so I know that might be real quick, but just try to give it a go, and I can help you in class about these. I'm going to end up doing, for this reading here, I'm going to end up doing just questions 1 and 2 here, and then on the next one too, and then we'll call it that. So calculate the acceleration from 3 seconds to 5 seconds. So if we have 3 seconds, I'm just going to circle 3 seconds and 5 seconds. So if I go up to here, 3 velocity is going to be at 2.5. So I have, I'm going to say 3 seconds. So acceleration is going to be on the time here. I'm going to have 3 seconds. Did I take that back? So I'm going to I have to do 5 seconds minus 3 seconds, and then see what we have here. We have 0 meters per second, and minus that by 2.5. 2.5, so that's going to equal negative 2.5. I'm going to put those units, meters per second, and 2.5 and 2, and if I do that, if I got 2.5 divided by 2, it's going to be pretty small here. 2.5 divided by 2, we're going to have a 1.25. Answer 1.25 meters per second. Okay. You end up doing number 2 and 3. Same thing here. Any questions on this? You guys end up rolling through, but I think you can end up going through these guys here. So the final thoughts with acceleration is velocity over time. Okay, the unit that is important to remember is that meters per second squared, and you can also, A is equal to V final minus V initial divided by T final minus T initial. Use this if you have more than one variable in each velocities and time. All right, let me know if I can help you.